Now to set this up, we'll create a simple sprite, and we'll use our favorite planet for the sprite. Whoops, daisy. Pick our planet here. And we will make sure that its position is someplace reasonable. So let's set this at 0, 0. And let's move over to where our camera is. You might notice this white line, that's from the user interface, so just kind of ignore that for now. And our camera, if I click on this, it'll show us what our preview is. We're kind of far away from our planet, so I'm going to just make us a little bit closer so we can see the waypoints. So something like that, and then we'll be able to see the object a little bit better. So we'll just call this patrol, because we're going to create a patrol system using coroutines. So from this, we'll then create a new script, and we'll call it C# script, and we'll say Waypoint Patrol. That's what we'll call it. We'll take this, drag it onto our patrol, hopefully. We'll look at this. Oops, I have 2 of them there, so let's go ahead and remove one of them. And let's go ahead and edit this so we can set it up for patrolling. Now, of course, the first thing we want to know is how fast we're going to move in our patrol. And this is, again, a simplified example, so we'll just use a public float speed, just so we can see how it works. And we also want to have a set of patrol points. And so I'm going to make a public list of, and I'm going to call it waypoints. I'm sorry, and I need to tell you what type it's going to be. So this is going to be vector 3. It will be called waypoints. And this is going to, if you know, come over here and you look at Unity, you'll see that I now have an array. Well, my array is 0, so I can set it to say 2. And once I do that, I'm going to have 2 elements that I can set that are going to be waypoints on the system. Let's go back to the code, though, and figure out how to do this with a coroutine. All right, so I'm going to also create a private variable called coroutine. Of type coroutine. That's going to be called path. And when I start my coroutine, I want to store this in case I need to stop it at some point. So you can imagine building a much more complicated AI system where you're patrolling part of the time and then you need to stop patrolling. And so you'd need to stop your coroutine. And so in order to stop your coroutine, you actually have to have a reference to it. Well, start coroutine actually returns the reference to it. So when we start it, when we say start coroutine, we can then get the reference to it. So patrol waypoints. And of course we don't have our coroutine defined yet, so let's define it really quick. And enumerator. And we can make this protected so we don't have to access it from outside. Then we will call this patrol waypoints. It's not going to take any arguments. Now, one thing to point out is that you'll notice that I have to execute this function. That's why there's extra parentheses here. It is executing this function by doing that. It's a function call, and it's executing it the first time so it can actually get the enumerator. And the enumerator is called as soon as I hit yield. It then builds that enumerator for me. So really, what I want to say is I'm going to loop forever. So I'll patrol forever inside my enumerator. And then here, what I'm going to do is create a for each loop. And the for each loop is going to go through my vectors. So for each vector 3 point in waypoints. And that's going to be the list of my patrol points. Okay. And then I can, help myself out by doing a debug log and say pathing to plus point. And this will let me know, in my log, like which position am I going towards at any point in time. Now, really what I want to do is use move towards, because move towards is going to give us an interpolation. And so what I can say is while transform position is not equal to point, then I'm going to do something. And, normally you don't want to compare vectors directly with each other. So you'd want some kind of nearly equals method in order to compare them. But because we're going to use move towards, it guarantees that I'm going to get at the final point if I pass it up. And so I can do a direct comparison. And so in addition, the equals method if you were to look at it, you'll see that there's actually a setup for the tolerance between comparing vectors, and so it's very nicely done. So we'll just say transform dot position is equal to vector 3 move towards, and I'm going to say my current position, transform position, my point, and my speed. All right, now once I have this, so update position using move towards. Then I'm going to, of course, do the typical yield return null, because I want to move a little bit, and it's going to be based off of the speed, so in essence how fast I can move, and I want it to return null at this point, so that I will yield computation. Otherwise I'm going to be stuck in this loop forever. I mean, if you look at this, I have an infinite loop here. And the reason it's not an infinite loop is because I'm breaking out of it with this yield return null every time I get into one path through this loop. I also remember that there's one more thing that we want to change. I can't just use speed as how far I can move. I need to change this to time, to multiply it by time delta time, so that it's frame independent. Otherwise, if the frame rate changed, it would move faster or slower. And also, you should save yourself a headache. And what I mean is that if you ever write an infinite loop, please put something like this in it. If you don't, and you try to run Unity, as soon as it hits the script and it gets started, it's just going to look like Unity's hung, and there's nothing to do but to kill Unity at that point. And it's really bad, because if you haven't saved your scene, all that information is going to be lost. So make sure you always have something like this here. I'm speaking from experience, so that no matter what happens here, because for example, if this was always returning false because you didn't have anything in there, then this loop is stuck, right? And you're gonna hang Unity, so you can't even change this in the editor, during playtime. And so instead, if you keep this in here, you'll always have access to everything. The coroutine will work the way it's expected by yielding computation back to the system. So with this, we should be able to hit play. It looks like it's compiled. And we'll see that if we look at my sprite, it's not going to move because my speed is nothing, and I have 2 points, but they're not anywhere. So besides its current location, so I'm going to set the speed to 1, and then I'm going to just change these values here, and we can see that we're now patrolling back and forth between these objects. And I can even change this dynamically, so that, and it's going to just change the last one. So I could say something like that. And then we'll start patrolling on these things. And so the coroutines, because they're reading current information, you can change their behavior. So you could change which areas they're patrolling while it's patrolling, and it will update properly, especially because I'm just using a for each loop. So I don't have to worry about, using an index and making sure I'm updating the index or whatever. It's just going to always grab the number of elements that are in there. And then, of course, can change during runtime. So this gives you an idea of how you set up something a little bit more complex with a coroutine, in essence, an enemy that patrols. And you'd want more complex logic if you're building a more advanced AI, but this would set up patrolling between some points, and all done with coroutines without having to figure out the logic for doing it in your script. And just to look at this one last time, what we're doing here is walking through the waypoints. We're checking to see if we've arrived at a waypoint, and then we're just moving to the next waypoint. And in between, we yield computation. This is a lot simpler logically than having to put this in updates separately, where you'd have to check to see constantly which position I'm at, and then update the current one I'm chasing basically in this update method and by having extra variables. So you get a lot of simplicity by setting it up like this. Now, the last thing we might want to do is perhaps we want to wait at each waypoint before we're done. And the way we do that is, you can stack coroutines. So I can say wait for seconds, and let's say 2. And this is now going to cause it to wait for 2 seconds at the end of each waypoint. And so you could have multiple coroutines that call other coroutines, and as soon as that one's done, it's going to go back to yours, and then it'll yield. So let's take a look at what this looks like now. Oh, I didn't save my value, so let me just put them in for future reference. We're going to say the speed is 1, We'll put a 1 here, we'll put a 1 here. That should be plenty to demonstrate what we mean. So now we hit play, and we'll get to the end point, we'll stop, and then we'll patrol back, and we'll stop. And you can imagine going back over here to the code. If this were a wait for seconds, then it would stop between points. This one stops at the end of a patrol, so maybe it's checking in with whoever's at the starting point of the patrol, and then it continues to patrol after that. So you can already see how we're building some pretty complex behavior through some simple actions and some simple code in our coroutines. And that pretty much covers it. The only other thing that you might want to do is stop your coroutine, and you can stop coroutines by actually calling stop coroutine. And so we can make a simple method here that we would call. So like say public void stop patrolling. Maybe some event is going to call it, or some other method is going to call it. And we just say stop coroutine path here. And that's the one that we got from this variable. So this would then call it to stop it. And then you could set up, something like, if input, key down, get key down, key code space, something like this, and say stop patrolling. And then, we can stop patrolling at any time. You could set something up to start patrolling, and then this will just give us the ability at any point after we've hit play to be able to stop, the patrol by just stopping the coroutine. And then you can restart it at any point by just calling start coroutine again. And then I just hit space. That's why it stopped. All right. Well, thank you. Hopefully that gives you a better understanding of coroutines, and look forward to seeing you again in the future.